About horizontal asymptotes. We're talking about rational expressions, okay? So we looked at last week, we talked about that rationals look like this, okay? And you started seeing a Desmos activity in a little less corner, more curve, where we saw that. We know that there's a vertical asymptote. That's what we were canceling last week. We know there can be a hole because that's what cancels when we do our rational expression. But there can also be what we call a horizontal asymptote in there. So today we're going to learn the algebra behind where that horizontal asymptote comes from. Okay. So the first thing, so we're going to fill out this little chart to kind of help us. If the numerator exponent is bigger, okay, so let's talk about what that means. So if I have something that looks like x over x squared, okay, which, if I were to put numbers in there, which one of those would grow faster, the numerator or the denominator? The denominator would get bigger faster. So that means I would have something small over something big. If I have something small over something big, when I divide that out, what value am I going to get? Think about that. If I put like what's that? It's going to be a decimal. Yeah, if I put that, let's say I put 10 in there, okay? So if I put 10 in there, I put 10 in for the x, I'd get 100 for the denominator. That's going to reduce to 1/10, right? Which I could write as a decimal point like that. If I rounded that, it would be about what? If I rounded it to the nearest whole number, what would it be? 0. Okay, so when I have something small and I'm dividing it by something big, I know that the asymptote is going to be y equals 0. Notice this week it's y equals because it's a horizontal line, not x equals. Okay, all right. It's not booger. It's supposed to be bigger. There's a typo right there. Okay. All right. I live in a house with 3 little boys. There's all kinds of boogers. Okay. But that's not even spelled the right booger. That's what it looks like in my brain right now. All right. The denominator exponent bigger. Okay. I just did that backwards, didn't I? That was supposed to say numerator bigger. So let me fix that. This is the one that was supposed to be down here. This is the small over the big. Sorry about that. And this is the y equals 0. Okay. I messed it up. I apologize. Welcome to Monday. Okay. All right. If the numerator exponent is bigger, so say I had x squared over x. Okay. So I've got the big one divided by the small one. Right. So my numerator is growing faster than my denominator. Okay. If my numerator is growing faster, it's going to be a big number on top. That's where our exponent is going to be y, or it's going to be our asymptote is going to be y equals, I think it's infinity. It's either y equals infinity or it does not exist. One of the two. There'd be none. Actually, I think we call it none. Let's go none. None. So you're not going to have a horizontal asymptote if your numerator is bigger. Okay. All right. And I'm going to double check that in a minute because I'm pretty sure that's what I put last year. All right, and then if my exponents are equal, this is actually a little calculus thing right here. We do it in a different way next year, but this is a little calculus, okay? If my exponents are equal, it is the coefficient, that says, let me write it here, coefficient of numerator, which I'm just going to call top, over the coefficient of the denominator, which I'm just going to call bottom because those are easier to spell, right? And it's going to be y equals that. So make sure you put y equals up front. It's coefficient what? Of the top divided by the coefficient of the bottom. And we're looking at the highest exponent because if we're going out towards infinity, the other numbers aren't going to matter. Okay, so let's talk about the nuts and bolts of how to do the problems. Okay, so first thing I want you to find the biggest exponent in this first one. So what's our biggest exponent in the numerator? X squared. What's the biggest exponent in the denominator? X squared. So what do you notice about them? They're the same. So I'm going to ignore everything else, okay? And I'm just going to focus on this right here, okay? If my exponents are the same, my horizontal asymptote, I'm abbreviating, okay, is going to be y equals, and I'm just going to look at the coefficients that are in front. So what number is in front of the one in the numerator? 3. What number is in front of the one in the denominator? 1. So my horizontal asymptote is y equals 3. It's quick and easy. No factoring needed, right? No factoring needed this week. You just have to look at the exponents. It should be fast. So if I were to graph this, my horizontal asymptote would be a y equals 3. Okay? All right. Looking at this one here. Okay? Number 2. What's the highest exponent in the numerator? 3. Oh, that's not what I wanted. What's the highest exponent in the denominator? 2. Which one's bigger, the numerator or the denominator? Numerator. So if the numerator is bigger, do I have a horizontal asymptote? No. No horizontal asymptote. Okay. All right. Last one. Okay, see, quick today. I told you 5 minutes. All right. What's my exponent in the numerator? Highest one. 2. What's the highest exponent in the denominator? Which one's bigger? Denominator. So if my denominator's bigger, what's my horizontal asymptote have to be? Not just 0, but y. Make sure you're typing in the y equals 0. We did okay on the x equals part, but the rest, some of it, we still had some confusion over vertical and holes last week. Okay. All right. That's all we're going to do on that. Okay. I want you to now find the learning log for 5.7 and open up the 5.7 quiz in Otis. Okay. I'm going to give you some instructions for what you're going to do when you sit down from the boards. Okay. We're going to do board work today. Yeah. So I want everybody to find this and also get Otis open. Okay. I'm going to stop that thing right there. Stop